This video is for the P3 task in 14.4, the assignment 14.4. We're looking at heat transfer processes, and in the video I'll go through the questions in the preliminary task. We'll be looking at a brick wall and how heat is transferred through the brick wall, also inside the room, because heat is not transferred through a brick wall via convection. So we'll look at how convection operates inside the room, and then we'll look at the differences that we can make to the heat transfer process by introducing a cavity into the wall, so cavity wall insulation, and by using low emissivity paint. So we'll get started off by looking at the heat transfer processes through the wall, which are conduction and radiation. So we'll take our wall here. That's my brick wall. And in this particular situation, the outside is about 26 degrees C and in is about 20 degrees C. So it's warmer outside than inside in this case. So the heat transfer will be from the outside in, because it's always from a warmer region to a cooler region, the heat transfer direction. Looking at conduction first. Conduction is all about the vibrations of particles, molecules or atoms. And outside we have air. Now, if you're looking at a gas and the air is a gas, then it's not the vibration of the molecules, but actually their speed with which they move. So this is hot. In comparison to the situation, the air out here is hotter. So we're going to have them moving fast. This is the molecules that I'm talking about here. Molecules move fast over here because they're very warm in comparison to inside. So they're moving fast, and they will collide with the wall, and inside the wall we've got molecules in here. And that will cause these to vibrate faster. So these collisions here will cause the outside of the molecules in the outside of the wall to vibrate faster. So then we'll get faster vibration here, and then the molecules on the outside will pass those vibrations on to the neighbouring molecules in the wall. So those vibrations will travel through the wall in this direction because they're passing on vibrations to the neighbouring molecules, so gradually it will work. Those vibrations will work their way through the wall like this. So we've got air out here, it's hot in comparison, so that means the molecules are moving fast. They collide with the wall and they cause the molecules on the outside of the wall to vibrate faster. Those vibrations are passed on to the neighbouring molecules. So you see how we're explaining how the heat is transferred from out here through the wall, and then when it's passed through the wall, that means the molecules on the inside of the wall are vibrating faster, and so that causes these air molecules, when they collide with the wall, to end up moving faster because some of that energy from the vibration is passed on. So vibration, energy transmitted to air molecules. And that's from the molecules on the inside of the wall. Okay? So those vibrations are passed through, and then it's causing the air molecules to move faster. So they heat up as well because they're moving faster as a result. So if I say here they're caused to move faster by molecules in the wall. So that's how heat would be transferred through the process of conduction, by either If it's gas, the molecules move faster, and the molecules inside the brick, they vibrate faster, and with larger amplitude as well. Then we have radiation. Now, with radiation, what we're talking about is heat transfer through infrared waves. So with radiation, we have hot objects out here, outside, and they emit infrared waves. Those infrared waves, some of them anyway, will be able to pass through the wall into our room, and they can heat up objects in the room directly. A lot of it will actually be absorbed by the wall, so the wall will heat up and you probably get some more conduction, but then the wall itself will also radiate into the room as well. But the point is that in the infrared rays can travel through the wall, some of them, and heat up objects directly. So objects inside. In fact, it's the objects and air. So the air inside will also be heated up. It's heated directly by the infrared. So infrared, the radiation method is very straightforward. You just got that direct heating by the infrared rays. So now we'll look at heat transfer process of convection. But unlike here with conduction and radiation, where the heat is transferred from the warmer outside through the wall to the inside, we can't do that because the wall is solid and convection can't occur in solids. It can only occur in gases and liquids. So for this, we'll take a room and we'll look at how heat is transferred by convection inside the room using the air inside the room. We'll need a heat source, so I might use central heating and look at a radiator. That's my radiator, which is hot compared to the rest of the room. Now, surrounding that hot radiator, there's air, so the air around here is going to get heated up as well. Now, actually, what I could do here is get a red pen. Red pen here, so that that air is getting heated by the radiator. Now, when gases get heated, or gases or liquids, when they get heated, they expand. And that makes them less dense, so they then will rise. Okay, so that heated air will rise up on this side of the room. Now, when the air has moved from there, that leaves space for air underneath to move in and replace it. So this is cooler air this time. Cooler air. And that moves to replace that air that has risen up, so that moves in here. That will then also get heated and rise. So we've got one, air is heated, expands and rises. Number two, cooler air replaces it, gets heated and rises. Now, meanwhile that air is being drawn in here, this air continues to move and it will move along the ceiling here and it will cool down. This is the air that was heated cools. That will cause it to contract and then fall, so it will become more dense. That's the key thing there. So it's more dense and it falls down on the opposite side of the room to the radiator. So it continues falling down here. And then here it can then move to replace and get reheated. So moves back to the heat source, which is the radiator, and gets reheated. So let's see if I can write this on. So the air is heated, cooler air replaced it. 3. Meanwhile, the heated air cools, becomes more dense, falls. Number 4, this air gets, the cooled air gets reheated. And so we've explained the whole cycle. We've gone all the way around there. And then this will continue until all the air in the room is at the same temperature. All at the same temperature. Because then you don't get a buoyancy difference between the air at different temperatures. Okay, so that is conduction, radiation, and convection. Now what we need to do is look at how the introduction of a cavity wall will change the situation for conduction, and then we'll look at low E paint as well, low emissivity paint. So I'll just rub this off and then we'll do another diagram up here.